Okay, so we're going to look at something called direct variation today. So it's actually as you're going to see today, kind of wrapping things up in this chapter, a lot of things that we've done are really the same thing, just with different names. And we're going to kind of see that near the end of this. Does anyone know what it means to vary, V-A-R-Y, or if there's a variation, what that means? If you vary or if there's a variation. Dula, what do you think?
Like differences?
Yeah, it's changing. Okay, and so a direct variation means it's changing the same every time. Is that similar to something we talked about last week? It's changing the same every time. A constant rate of change. And that's actually going to be pretty much the same thing. A direct variation is very similar to a constant rate of change. And so what that is when two quantities have a constant ratio or a constant rate. Well, if two things have a constant ratio, they're also proportional. And so direct variation is the same thing as proportional. It's just a different term. And then the constant of variation, that is what the constant ratio is. And so notice what other things we can call the constant of variation. Unit rate, slope, and constant of proportionality. All three of those are things that we've already talked about. Same thing, just with different names. And we've also already talked about the direct variation equation as well. We used that last week when doing some of those questions. So hopefully you remember that equation y equals kx, and we did the unit rate. Step 2 was the equation. Step 3 was plug in. That's the same equation that we used then. And so we'll find the unit rate, and k is the unit rate. So if you want to make a note of that, k right here is also the unit rate. Or the unit rate, or the slope. And remember yesterday we said slope is what over what? Y over x. K, the unit rate, or the slope, is y over x. And so if you've got to find the unit rate, or if it says find k, the constant of proportionality, then we would do y over x. Figure out what y is, what x is, and then put that y over x. So like we did yesterday to find the slope. Okay, so a few other things dealing with direct variation or proportional relationships. So we would say, the question's sometimes going to say, does y vary directly with x? And almost always we're going to be looking at a graph. And so if the line is straight and goes through the origin, then it's a direct variation, or it is proportional. And so this second bullet point, that's basically what we're saying. A direct variation relationship is the same thing as a proportional relationship. On a graph, remember we talked about, I think it was last week. Yeah, we said last week the unit rate is where x equals 1. Well, x is 1, and that's where that unit rate is going to be located. So we talked about that last week as well. Okay, and this last point, not all linear relationships will be direct variations. So a linear relationship means, what does it make? A straight line. Why would not all straight lines be direct variations? Or not all straight lines are proportional? Why would that be the case? Why would not all straight lines also be proportional? What's the second criteria? Straight line. So it could be a straight line, but it doesn't go through the origin. And so not just because it makes a straight line doesn't mean it's going to be a direct variation. We still have to graph it and make sure that both of those criteria are met. Okay, so we've talked about 3 different reasons why something is proportional, right? Straight line through the origin, constant ratios, the same unit rates. There are now also 4 names for a unit rate. So the first name for a unit rate is exactly itself, the unit rate. The second name for a unit rate is what we talked about yesterday, and that is slope. The third name for a unit rate is the constant of proportionality. And then the fourth one is the one that we just wrote down on our vocab, constant of variation. So make sure that you've got this down on your paper, because like I said, you will probably have a question in the future that says, what are the 3 reasons why something is proportional? And we saw it last week on our bell work. You're going to have a question in the future that says, what are the 4 names for a unit rate? And these are it. So the unit rate, slope, these 2 are the hardest ones to remember. Constant of proportionality, which is just the unit rate, and then constant of variation. All 4 of those things are the same. It's what number is the unit rate? What number is the slope? So hopefully we're kind of seeing today, especially, how all these things are really the same. They all kind of work together. Okay? So let's look at some questions on, is something a direct variation? Remember, direct variation is the same thing as proportional. Unit rate's the same thing as slope and constant of proportionality. So all these things are what we've done so far. So the first thing is the height of the water as a pool is being filled is shown in the graph. Determine the rate in inches per minute. So in other words, we've got to find the unit rate or the slope. So to find the unit rate or the slope, what number goes on top? Y over x. So what we're going to do is choose one of these points, like what we did last week. So what's the point we could choose, Vincent? 20 and 8. So we're going to put y over x. So which one is y? 8. Remember, it's x comma y. So x is 20, y is 8. So it's going to be 8 over 20. What do you think we should do with 8 and 20? We're not going to subtract, we're going to simplify this time. So we don't have to subtract anything because we just put y over x. So we're going to simplify it. We can divide both by 2 or by 4. And we should get 2 over 5. 2 over 5. Just to make sure that it's the same for all of them, if we chose this point and did y over x, it would be 2 over 5. 4 over 10 can simplify to 2 over 5, as can 6 over 15. So 2 over 5, that is y over x. That is the unit rate or the slope. All right, so any questions on that? Just picking out the unit rate. There's a lot of different kinds of questions we're going to look at today. So this second one doesn't give us a graph, but it does give us the equation. The equation y equals 10x. That represents the amount of money, which is y, that Julio earns, for x amount of hours that he works. So the first thing is identify the constant of proportionality. So remember, constant of proportionality that is the same thing as unit rate. And so look back at the vocab that we wrote down. Where it says direct variation equation, what letter was the unit rate? K. And where was K in that equation? It was right before the x, right? Y equals kx. So what's in the place of k? And that's it. That's the constant of proportionality. So if it says what's the constant of proportionality or what's the unit rate, we would just say k equals 10. Because that tells me you know that the constant of proportionality is really just k. And it's just that. So you don't have to do any work, you don't have to do any math, it's just k equals 10. And that's the number that's right in front of x. And then we also need to explain what it represents. Well, k was y over x. What is y in this situation? Amount of money. And what is x?
Hours.
Money over hours. So the constant of proportionality, it represents, how could we say this? Money over hours. What's another way we could say that? It represents how much money he gets per hour. How much money he gets per hour. Very good. So if it says find the constant of proportionality based on the equation, we're just going to give the number k equals whatever that is and then explain it's y over x. In this case, it'd be money per hour. Okay? So let's look at another one together. So they've got the distance. So one thing you might want to do when they give you this information, go ahead and say, okay, k equals y over x. And what is y that they tell you? Distance in miles. So let's say miles, and what is x? Hours. Okay? So that'll help us identify the constant of proportionality. What is k equal to? 55, just the number right in front of x. And then what does it represent?
How many per hour?
Yep, how many miles they go in an hour? What's something else that miles per hour would represent? And if you wrote this, I would count it correct. Miles per hour measures the what? The speed. So if you want to say it's also the speed, I would count that right as well, because that's what miles per hour gives. So picking out what K is that number in front of X, and then explaining what it means, how many miles they go per hour. All right, any questions on these two so far? All right, another thing that we're going to have to do, and we've actually already got practice doing this, is writing the equation. Okay? So 2 minutes after a diver enters the water, he's descended 52 feet. After 5 minutes, he has descended 130 feet. So first question, at what rate is the diver descending? Rate right here is actually the unit rate. So that's what we're trying to find. And the unit rate, or K, or the constant of proportionality, or the slope, is always y over x. So what two units do we have in this? Let's continue to answer like we've been doing the past couple weeks. What are the two units that the scuba dive, feet and minutes? Which one is going to be x? Which one is usually x? Time is usually x for minutes, so it's going to be feet per minute. Okay, so we've got 52 feet in how many minutes? 52 feet in 2 minutes, right? 2 minutes after he descended. So we'll simplify that. 52 divided by 2 would be 26. Okay, and then 130 feet in 5 minutes. Divide that real quick and tell me what you get.
Oh,
26. Should it be the same?
Yes.
Yeah, it should be. If it's not the same, it's not proportional, or it's not a direct variation. So we want it to be the same. So it is the same, which means the unit rate, or K, equals 26. So the last thing is to write a direct variation equation. Well, that equation is y equals kx. And what does K represent? It is the what? The unit rate. And we just found the unit rate, which is 26. So our equation is going to be y equals, that's it, y equals 26x. So once you find the unit rate, you just plug that in for K, and it's going to be y equals the unit rate times x. Okay, so any questions on that? So just kind of taking that one step further and plugging into the equation, making our own equation once we find the unit rate. All right, so the last thing that we're going to do, and this is stuff that we did yesterday, we did last week with graphing. We're going to graph the relationship, and then we're going to answer this question: is there a direct variation? Remember, direct variation is the same thing as what? That's constant of variation. We said if something is in direct variation, it is actually, starts with a P in the word that we've been using in the past. Proportional. So direct variation is the same thing as proportional. Which means, what has to happen for this to be proportional? What does the graph need to make? Straight line that goes through the origin. So if this graph makes a straight line through the origin, then it's going to be a direct variation, or it's going to be proportional. Okay? So let's first make a table with 1, 2, 3, and 4 pizzas. So we've got pizzas and we've got the cost. Which one will be Y? Which one is usually Y? The number of pizzas or the money? The money or the cost. So cost is going to be Y. Pizzas will be X. If you get one pizza, how much does it cost?
$8.
$11.
Yeah.
$8 plus the delivery charge. Now, how many times do you add the delivery charge for every pizza? Just once. So 2 pizzas will be 2 times 8, which is 16. So how much do you have to pay total? $19. Add that $3 charge. 3 pizzas would be 3 times 8, which is 24. But then add the $3 again, would be 27. And 4 pizzas would be how much? 35. So just looking at this information, do you think it's going to be proportional?
Nope.
Probably not, because these unit rates are not the same. So we still need to graph it. We got to get up to 35 on the y-axis, so maybe go up by 5s. Go by 5s. One pizza's at $11. 2's at 19. So if I started at the origin and then connected these, it would not make a straight line. Or I could just connect it all the way through and it wouldn't meet the origin. So whichever way that you want to make this graph, either make it not a straight line or make it to where it doesn't go through the origin. But we already see that it's not going to be direct variation or proportional. And so the answer would be no. Okay, so you all go ahead and do the last one on your own once you get that one. Graph that last one and then tell me, is it direct variation or proportional? Okay, so you've got pounds of steak and cost. Pounds will be X and cost will be Y. So 2 pounds costs $7. means 4 pounds is going to be 14. So 1 pound is going to cost how much? $3.50. And 3 pounds? $10.50. Good. So when we graph this, should we get a direct variation or a proportional relationship? We should, yes. Because we get a straight line and it is going to go through the origin. So yes, it will be direct variation. Okay, so kind of to wrap up, and this is good with wrapping up pretty much everything that we talked about with this chapter. Direct variation is the same thing as proportional relationships. And the 3 ways that something is proportional are, what's one of them? Somebody give me one. Vincent? Straight line through the origin. What's the second one, Charlie? Constant ratios. And Wanda? Same unit rates. Okay, the unit rate is what letter? K. And K equals what over what? Y over X. And what are the other 3 names for unit rate? Unit rate, constant of proportionality, slope, constant of variation. So everything's kind of working together now. Just remember the other names for something, and you're going to be able to remember what you've got to find and how you can find it. Okay? So a few questions to work on for today.